So let me first introduce the first morning speaker for this track. His name is Gareth Thomas. Maybe he's actually interested. Show of hands. Who knows who Gareth is? It's not too much actually. So
Only on that side. Those are my friends.
yes,
And these
yes,
will
good,
become
good.
my friends.
Yes. So actually, not related to the topic of the talk, but more Gareth has been very crucial in making both PyData and JuliaCon happen here in Eindhoven, because he's been basically involved in organizing meetups for the past 3-4 years or something like that.
MATLAB,
So
Python, and Julia.
MATLAB, Python, and Julia, and so it's really great that he's able to give this talk here as well. In preparation of in the lead up to this, we've had plenty of discussions on the Julia side of MATLAB versus Julia and all of the different conversations. Those discussions lasted, I think, in the hours, maybe even. So I'm very curious how you'll be able to summarize that in 30 minutes. So here you go. Give a round of applause to Gareth.
Thank you very much. Good morning, everybody. How are we doing? You enjoying the show so far? Yes? So just a quick hand raiser. Who here actually uses MATLAB? So you all use MATLAB. Which conference are you guys in? Okay, good. Okay. Who here actually? The first user in the user. So I'm going to shake your hand, sir. Thank you very much. Big round of applause. So this is cool. That's kind of unique. I wasn't expecting that. So my name is Gareth. I'm going to be talking about my first 10 hours in Julia, right? So to understand my talk, you have to understand I used to work for the MathWorks. So I spent nearly 10 years of my life working at the MathWorks. So it kind of shaped a lot the way I think and see the world. That being said I left the MathWorks, created my own company. I have 2 kids, and I've always wanted to create my own company. So I said, okay, I now have learned as much as I can from the MathWorks. I'm going to go and create a company. Created a company, and what we do is we're a bunch of MATLAB, Python, and Julia consultants, right? Okay, and my screen disappeared. Okay, very good. So I really only have for this talk to kind of 5 things that I want people to remember, right? Typically it's 3, 5, odd numbers are good. So, number 1, independently of MATLAB, Julia versus, I think curiosity is key. Everybody should be curious, right? 2, respect language diversity, right? 3, listen before prescribing. 4, don't ask how can I, ask what is the right way to. And 5, turns out that learning is an investment. So why did I choose these 5 things? Well, it turns out that tools and languages are always evolving at an ever fast pace. The only way we keep up, we stay curious. And it turned out by learning Julia, or exposing myself to Julia, it actually solidified a lot of concepts that I thought I knew in MATLAB, and I wasn't really sure about it. So it triggered me to think more about my own understanding of the place where I was most comfortable, okay? And it's very interesting, when you speak to Julia folk, they say, Julia's super fast. But that only matters if MATLAB is perceived to be slow. So here's a question. Is MATLAB slow? So don't say Julia's fast to MATLAB users. It doesn't work. That doesn't solve anything, right? Just like doctors. Listen to why people don't like your language or want to change, and then it's better, right? And then it turns out that to be good at the new language, it's very, very common for engineers. Just get it working. It's working. We move on, right? But we never go back and think, well, what would have been a better way of doing it, or what is the right way of doing it, right? So mastering a new language, there are gotchas in every language, and it takes time to master those. And because it takes time to master them, you got to make your peace. If you're moving from one language to another, it's an investment. Make your peace and say that we're actually going to be not as efficient as you used to. So I was a strong MATLAB user. And then when I started using Julia, my productivity went down, down, down. I don't care what people say. It went down because it's like, yeah, there's all these gotchas that is like, I have to Google more. Oh dear. Okay, Google, help me out. How do I do this? All right? So these are things I want to take away. So a bit about myself. I'm a control engineer. I studied in Portugal, worked at Siemens, worked at the MathWorks, and I created my own company, Version Bay. What am I going to be talking about? Change, right? MATLAB versus Julia. I think it's about understanding the 2 ecosystems and figuring out which is the best one for your tools. When you look at organizations and people looking to shift between things, you need a vision, you need skills, incentives, resources, and if you get that, change happens. If you miss some of them, you start noticing people get anxious if they don't have the skills. If you don't have the incentives, things don't move fast enough. So I'm focusing a bit about the skills and the incentives here, all right? High level, scientific computing journey, you can see yourself as a newbie, someone who's just starting, maybe a casual user, maybe someone's proficient, or maybe someone actually developing tools for others, right? There's a spectrum of how good you are in languages that we all go through this journey, right? Turns out each of these categories of folk feel and struggle with different things. I consider myself a MATLAB developer because I've worked a lot with it and I help building tools for others in the MATLAB ecosystem. So I said to myself, I'll start with Julia. I'll be proficient. I mean, I'm a smart guy. How hard can it be? Well, it turns out that this is much more realistic, right? I am a newbie in this. So remember, this talk is my first 10 hours in Julia, and I'm sharing all the things that caught me off guard, which I think are useful for others to be aware of, all right? So enough of slides. Let me talk a bit about the problem I want to solve. So if I'm a newbie, right, how do I get started? How do you get started in Julia? Well, install Julia. Okay, great. But that's fantastic, install, okay. But then here's, well, what problem do you want to solve? So starting thing is I want to explore Julia and plot a 3D sine wave and have a function that has an input of frequency, right? This is like as basic as it gets. If I can do this, great. But I want to walk you through what that looks like. So how do you do this? We start the REPL and let's try VS Code. All right, so congratulations, we're in the terminal. So let's do this, cd demo 1. Okay, so you start Julia. You've installed Julia. Great. This is fantastic. All of a sudden I'm lost. My key things that I start over don't work. Okay, so how do you do this? So it's Control L. Okay, I can clear it. But it caught me off guard because I didn't want to see Julia, I just wanted the prompt, right? Okay, so how do I plot a sine wave? Well, actually, before I do that, in Julia, there's a couple of things. You have this REPL that changes based on the commands. It's kind of cool. You have help. You can have access to the Julia command prompt. You can add packages, the package environment. For the Python folk, that's kind of a weird thing. The pip install env, it's always kind of confusing. Julia integrated nicely. But I'm going to actually do activate dot. What is this? I just created an environment. That's kind of nice, right? Now, let's do a bit of programming. T equals. So far, so good, right? Yes, good, we're nodding. Now, I want to plot a sine wave. Y equals sine of t, right? Does anyone find this weird? Okay, so what went wrong here? First MATLAB user on the planet. What went wrong here?
The mathematical definition of sine works on scalars.
But I abuse that. Wow, okay. So I'm not the first MATLAB user, but what does it say? Method error, no method matching sine, step, range, float 64, base, twice precision, float 64. How do you debug this? Okay, so there's a help, sine. Okay, so there's a few examples. Still not clear. But then it turns out that there's this funny thing, which is actually pretty powerful once you get it. It's the dot. It's broadcasting it. So, okay, so you look at this, and then what you really want to do is sine of dot of t. Okay, that works. Great. So now I understand, right? So the way that instead of writing a for loop, Julia does this broadcasting in because sine mathematically represented as a scalar.
Used to pronounce .NET as broadcast, but as pointwise. It's a point. It's a decimal point.
It's a decimal point.
So it applies pointwise.
Pointwise, yeah.
So even though MATLAB doesn't do sine dot, Cleve invented the sine dot anyway.
Funny how the world goes.
Yes.
But it is interesting, as a MATLAB user, this caught me off guard, right? So now what do I want to do? Plot, right? What's missing? Oh, I need to add my plots. Okay, now that I've added my plots to my environment, right? So now I go using. So you want to use a package, you have to know this. Once you get used to it, it's fine. Great. Okay, cool, it works. But it's not very flexible, right? Doesn't move, scrolling, that's not so nice. Okay, so now what? I don't know. ChatGPT, maybe? Or can we do this? This, I think, is a realistic scenario, right, in today's days, right? Is this a reference of golden truth? I don't know. Oh, add plots. I got that one. Good. Well done, Gareth. Example data. Yes, I got 2 vectors. Kind of right. Really? Plot x, y, z, series, surface. Okay, that looks a bit clunky. Is that what I really need to do? Not sure. So let's see if I get this. Why don't I do, first I need to get a mesh, right? So let's see how this works. Does this work? No, because I need to transpose it. Yes, we agree. That makes sense. So do I want what? Y times y transpose. Does this work? Okay, that's not exactly what I wanted. So I kind of say, well, maybe I want a surface. Surf, so I come from the MATLAB world. Does surf exist? No. So tab completion. Oh, surface. Okay. T, and then let's do y times y. Good. Okay, good. We're rolling. This is good news, right? It took me 5 minutes to get this, right? It's a bit of thing. So this is an experience which I think is kind of interesting. But then there's another thing of like, but I still can't move it. So how do I fix that problem? You go to plots, and you say, oh, plots. And there's different types of plots. Oh, I can use Unicode plots. What's this? Does this work? So if I do that, Unicode plots, does it work? Oh, no, I need to go here, add Unicode plots. So double tab helping me out. I need to add a package for this to change the backend. Hold on. I'm going to change the backend of plotting? That's possible. It's kind of cool, right? So let's try this again. We go up to our history. That didn't work. Why? Because I need to tell it that I want to use it. Wait for it. Sorry. Good. Kind of cool. So it turns out there's a whole bunch of ones there, right? Unicode, not so important. There's a whole bunch of them, Plotly.js, and you can kind of do things. But you need to know this, right? So there's a bit of searching that is involved to do that. But there's a few other things that kind of caught me off guard, is you can also say f of x equals sine dot x. I just created a function here, right? That looks pretty elegant. I like that. That was sweet, beautiful, elegant, like a mathematician would think, right? And there's other things, and just because my title is an interesting title, I'm going to do something cool, which is this. Let me see if you find this funny or not. MATLAB equals 1, 2, 3, right? And then if I say Julia equals sine of x, let's do this. Okay, what I can say is Julia MATLAB. That makes sense. But it turns out most of the planet reads left to right, not right? So you can actually do this. It's kind of cool, isn't it? No, people didn't find this funny? You did find this funny. Okay, so the first time I saw this is, what on earth is going on? So I had to Google it. I didn't know what that sign meant. I don't even know what this right term is. Is this the pipe command? No. Pipe, right? So I was like, oh, the piping looks nice. That's kind of cool. So these are just a few things that kind of caught me off guard as a newbie, right? So let me walk you through that. Am I clear? That hurt me at the beginning, but okay, that's a small thing. The REPL's got a whole bunch of things which I wasn't used to. So it's got for package management, environment, access to the shell, documentation. Using plots, if I'd done this, it will prompt you that don't forget to install your packages, which is kind of nice. I like that a lot. My osine.t, that caught me off guard. Once you know, it's okay, but it's that first few hours is like, oh, don't know. What did I do wrong? What did I go wrong on that? The 2pi, I don't actually need to do 2 times pi. I can just say 2pi. That's kind of sweet. I like the way that the functions are written. It's kind of like how a math teacher would teach it. And yeah, the piping was cool, but I had to Google what I was doing it, and I felt very proud of myself. I felt like I've achieved, the next badge in my Julia journey and whatnot, right? So those are some of the things that caught me off guard. Now, if I go to the casual user, so how am I doing for time, Irvin? How many minutes have I got left?
About 10.
10 minutes. Okay, cool. So we're going to do something super cool here. I would like to inspire my 5-year-old to use a new programming language. How do I do that? Python world uses turtle, so let's use turtle. Does everyone know what turtle is? Good. If you don't know what it is, I'll walk you through it. And I'll show you how this is done. So I discovered Pluto. What is Pluto? Okay, so this is kind of an interesting thing, right? So if I do this, I didn't need to do it like this. I could have done it in Julia, but I'm going to do it anyway. Julia. I'm going to go activate my local one. Just so you know, I've already pre-installed Pluto, right? What is Pluto for those of you who don't know? You do import Pluto, then you do Pluto run, right? So this is kind of like similar, I guess, to the MATLAB live scripts in some shape or form, and I'm going to create a workbook, right? So this is maybe like Jupyter Notebook, but Pluto is a little bit different. So let me do a quick little example here. Use a few packages, Luxor, colors, and I'm going to use Pluto.ui. Oh, good point, good point. I should have prepared for this. Does that work better? Thank you very much. So I'm going to import some things. It's going to do it in the background. I'm connected. So Pluto makes life easy. It takes away the adding packages behind the scenes. And I can define a variable, so that's great. You have these cells. I can say y equals like that. That's kind of cool. But what is super special about this, kind of cool, is I can change this number. Look what happens to y. It got updated automatically. See that? And here's another cool thing. It actually doesn't matter the order. Did you see that? Nice. Feels like Excel again. Excel does this. Okay. A couple of things. Okay, so then you can do, oh, sorry. Bear with me. Oh, I did that. Variable not, okay, yes. Okay. I apologize. What is my next step that I want to show you? How about this? MD triple dot. This is a slider. Okay. Dollar bind X slider 180 default 80. I think I got that right. And I'm going to do this. It's kind of cool. Oh, I missed my X. See what's happening to my Y? That's smooth, very responsive, right? Why is this interesting? Okay, so function, my turtle. I want to show you the turtle thing. Bear with me as I type this. Drawing, live docs, let's show this. As I tells me exactly what I need. Okay, origin. I want to draw turtles. We'll get there. Bear with me, all right? Right? T equals turtle. I want to go forward. T, 100. I want to turn. T, 60 degrees. Forward. T, 20. What do I want to do? Finish. Preview. Why am I doing this, you might wonder? I just defined a function, and then I can call my function, right? My turtle. Where did I make a mistake? Sorry? Forward there. There we go. See what happened? I put a turtle down, moved 100, turned my angle, and went down, right? Why is this kind of cool? I guess you can see where I'm going with this, right? Angle, right? Let's remove this. Let's do some, because Irvin said I had only a little bit of time.
So you need 5 more minutes and then questions for 5 more minutes.
Very good. Let's do this. +1, and I'm going to angle. I think you're all following what I'm doing, right? That's kind of nice. Define my function. Oh, my turtle's not working. Why? Because I need to give it X. Did you see that? So let's hide a few things. Actually, no, let's bring this up to the top. Let's do this here. This is the image. Look at my slider bar. Isn't that cool? You can change the pen with the colors, you get it, right? That was nice. This is how I can draw cool things. That was kind of elegant. But you could argue that there are more things, right? So this is just a starting point. My discovery here was Pluto. It took me a while to figure out its existence. Once I did, this was a much easier way to get started. So I'm going to go back to my slides now. And I also used an example of data frames. So MATLAB has tables. Data frames in Julia are very powerful. But you have to get your head around them a little bit. So remember that piping idea? The data frames work a lot with that, so that makes it interesting. So if you read this line, first, unique, sort, data frame, join, group on, right? It's actually easier that I'm taking the data frame, these two columns, I'm sorting it, I'm looking for the unique, and I'm looking for the first 10 elements. I think it's arguable that this is maybe easier to read for the first-time users, all right? There's a thing that caught me by surprise, that for loop. If you do this for I equals 1 to 10, you print the I, that's great. But outside the for loop, the I disappeared. The variable disappeared. It's out of context. It was like, what on earth happened? It disappeared. Where did my I go? It took me literally 20 minutes to figure out that that's a thing in Julia. So context makes an important difference, right? They've also got the transformation stuff. So anything that MATLAB can do, pandas can do, data frames can also do. That's great. You just need to get used to it. But I did like the slider bar. That widget was cool. MathWorks also has it, but I think I found this a little bit more responsive, right? That drawing was pretty slick. The order, that's a nice touch. That only applies to Pluto, not to other things. So really cool things that happened. I think Pluto surprised me. I was not expecting that, but it took me a while to discover it. Just as a sanity check, then it's okay. This is not just playgrounds. I'm a control engineer. I try to use it with a control example. At the MathWorks, I was used to use a PID controller, and I would do auto-tuning, and it turns out that Julia has the same thing. Very clear, very easy to use, and I was very impressed with it. The way that this works, you can use Visual Studio Code. Let me show you how this works, just as a quick demo. I know I've been given the card. Bear with me. Visual Studio Code, using control systems, Control-Enter. It's running, loading the control systems package, and I'm going to use plots. Great. MBK, this is a mass spring damper example, the classic one that all control engineers use. Notice as I tick through what's appearing here in my REPL, I got a transfer function, I create a PID, just created a feedback loop. I'm going to do a plot. It appears. I'm going to use loop shaping PID. This is the auto-tune. Let's do the feedback loop again. Plot. Oh, I just automatically tuned a PID. That's pretty cool. Yes? And it actually gives me nice little additional graphs for free. So for a control engineer learning out, I would argue it checks off a lot of boxes. So it's not just for playing, right? The documentation is pretty good, and I like that. That surprised me. So as a control engineer, I was like, oh, there's something here. Some of these packages are deeply thought out. Problem 4, it's all about sharing things. I won't go into too much detail. I'm the author of jokes.jl, because in conferences, in these awkward silences, I like typing jokes. Use it, give me feedback. It's kind of fun. Can I do this? Okay. So I'm going to stop this for a second. This is self-proclamation using jokes. That's what I created. I mean, that's as far as I got to deploying it. But I wanted to just see the workflow to deploy a package. Is this kind of funny? There's no why, so I created my jokes. Okay, very good. Never mind. But the interesting thing about that is actually the process behind it. I think the Julia community has done it really well. The packaging, I think, is well thought out of. The test, the way you write tests is a little bit different, but it works, and it's kind of forcing you to write tests, which I kind of like. The documentation out of the box happens nicely when you publish a package. The documented JL makes life a lot easier for doing that, and I appreciate it. It looks consistent. And the other thing is when I published jokes.jl, it took me literally 24 hours, and some dude, Benoit, maybe some of you know him, he looked at my code and said, dude, that's not how you write code. What? What happened? So let me show you. This is me as a MATLAB user. How did I type that? So maybe this was not the best example, but I was tired and I created jokes, random. No, this, and then Benoit said, dude, just do rand jokes, right? Maybe I should have just read the documentation. But it was nice as the community stepped up and helped me teach me a little bit more, and I was appreciative of that. So it turns out that it's not as hard as you think to create a package. It's very nice. Modules are important, but you have to use include, so there's a few gotchas in that. Testing and test items is nice. The community helped me, and the tag block automation documented.jl really makes life easy to publishing packages. I'm very grateful. So on that happy note, I'm going to ask you quickly, what were the 5 things that you were supposed to remember? Sorry? Jokes.jl is not what you were supposed to do it, but if you give me a star, I'll be happy. So I want to end this talk very quickly saying, curiosity is key. Don't be scared to be curious. Look over the fence, see what others are doing, and think about it. Be critical, right? The other thing is respect language diversity. Seriously, I learned things from Julia, but it solidified my MATLAB knowledges by doing that. And I think the same holds true in both directions. Listen before prescribing. If MATLAB is not perceived to be slow, stop saying Julia's solution is fast, and that's why you should use it. That doesn't help. And I think it's why should we use Julia? So we'll get into the questions just now, Paula. Let me finish the 3 points, and we'll take it. There's a microphone that will help you. All right. Last thing is, ask how to do the right thing. So Benoit taught me how to write better code. I'm grateful. I should have actually, at that moment, before I published, take a step back. There's got to be a better way. That looked ugly. I should have thought about that. And learning is an investment. So with that, thank you for the talk, and let's take the questions then. Very good.
So I will ask you, like I did not hear the previous workshop.
Okay, very
he
good.
actually gave already a hint why we should use Julia, but asking you why.
So why
Why Julia?
So this gentleman here says the cool people are using Julia. So that's one way of doing
Just
it.
to be cool, then.
I think languages come from different backgrounds, right? So MathWorks grew from a particular area. Engineering, science, electrical engineers kind of learn about it. I think Julia has its strong suits, not necessarily in engineering, but more mathematical-minded folk. And as the community grew, it also expanded into different domains. So I think there's certain problems where I think Julia is really good. So the mathematical computation in some places I think is really fast, right? I think the power of going to GPUs on all architectures, MathWorks doesn't support all of them necessarily. The GPU, high-performance computing, the Julia community solves that. And I think their strength is really downstream. So it's not at the beginning, but if you're a developer, a scientific-minded person, developer who thinks about these things, Julia is actually very attractive. But for newcomers, it's a bit of a journey to get there. And I think the MathWorks kind of does it the other way around. For newcomers, it's a much more embracing feeling. But then if you want to go to high-end things, maybe outside automotive or aerospace, or you're not doing safety-critical applications, then Julia is actually okay. But I mean, every car we drive, every plane we have, it's got some MATLAB behind it. So respect language diversity, right? It's something cool that the MathWorks did. I think the Julia could take a few tricks from that, like certification, deployment. There's some cool things there. Yeah? More questions?